Problem 45, we're asked to consider two different structures. They look like they're the same molecule, but they're just different conformations. And we're asked to decide which is higher in energy, and then calculate the energy difference between the conformations using table 4.3, which I've snipped out a portion of it. So what you want to do is identify sources of strain. Now we have a methyl group here bumping into another methyl group here, and that's called a gauche interaction. And then we have a gauche interaction here, and we have a gauche interaction here. There's no other sources of strain in these two molecules, these two conformations shown in part A. So to calculate that, we would take, there's 3.8 kilojoules per mole of strain right here, and there's twice that here. Okay. So you would just take the higher energy minus the lower, and that's the energy difference, right? So the energy difference is 3.8 kilojoules per mole. Okay, and that's the energy difference, all right, between the bottom structure and the top structure. So this is the higher energy, and that's the energy difference, okay? For the pair given in B, again, we have two different conformations, and we just want to examine. So there's a gauche interaction, and then there's a gauche interaction. So that's a total of 7.6 kilojoules per mole, right? 2 times 3.8. So the energy of this one is 7.6 kilojoules. Down here on the bottom, we have some eclipsing or torsional strain. So we have a hydrogen and a methyl. That's worth 6 kilojoules per mole. We have a hydrogen and a methyl. That's worth 6 kilojoules per mole. And we have a hydrogen eclipsing a methyl, which is worth 6 kilojoules per mole. So that's a total of 18 kilojoules. Now, when you're deciding which one's higher in energy and lower in energy, you can always bet that an eclipse conformation is always going to be higher in energy than a staggered. So this definitely is higher in energy, and we obviously can see that because we have 18 versus 7.6. The energy difference here, you can just calculate it from, you know, the difference. You have, you know, this math here that you're doing. Kilojoules, okay?